Hello. So let's say we wanted to divide 39,872 divided by 7. And we want to know, is this big number divisible by 7? Or in other words, if we divide 39,872 divided by 7, will we not get a remainder? So a really weird and mysterious way to divide by 7 and to know if our number is divisible by 7 or not is to do the following. We start with our original number, and then we just delete whatever the last digit is, in this case 2, and then we subtract 2 times whatever we just deleted from what remains. So in this case, we delete the 2, and then we take 3,987, subtract 2 times 2, or 4, get 3,983, which I have no idea if that's divisible by 7 or not. So then we can delete the 3 and subtract 2 times 3, or 6. We get 392. Still have no idea. So then we can subtract the 2, or delete the 2, and then subtract 2 times 2, or 4, from 39. And we get 39 minus 4 is 35. And then, I happen to know that 35 is 7 times 5. So therefore, the original number, 39,872, must be divisible by 7 as well. Huh? That seems so weird and mysterious. Why does that work? Well, let's go ahead and explain this cool divisibility rule for 7 with exploding dots. Namely, let's look at a 10 to 1 machine. So here we have a 10 to 1 machine, and we have 3 dots, 9 dots, 8 dots, 7 dots, and 2 dots. So therefore, we have the number 39,872 represented in our 10 to 1 machine. Now, to explain this trick, we want to delete the final digit. In this case, our final digit is 2. So we have 2 dots. So we want to delete those 2 dots. So to delete the 2 dots, well, we'd have to have 2 anti-dots in that box. Right? We have 2 anti-dots and 2 dots. Anytime we have an anti-dot and a dot together in a box, they annihilate each other. So let's just assume we just had 1 dot in our last box. Well, then, if our original number is divisible by 7, we can add as many multiples of 7 as we want. That's not going to affect if our number is divisible by 7 or not. We're just looking for a yes or no. Is this number divisible by 7? So if we just had 1 dot, and if we delete that digit, we'd have to add an anti-dot. So to have a multiple of 7, we could add 2 anti-dots in this box. Because if we have 2 anti-dots next to 1 anti-dot, that's like a negative 21, or an anti-version of 21, right? And 21, or negative 21, is divisible by 7. But in this case, we have 2 dots in this box. We want to delete both of them. So in general, if we have D dots in our last box, we want to add in D copies of negative 21, right? Two anti-dots next to 1 anti-dot, which is going to delete all the dots in our last box. But then, right, it doesn't affect if our number is divisible by 7 because we're adding in a multiple of 7. But now look what happens. If we have these dots are going to explode away, annihilate each other, and then we have 4 anti-dots, which are going to annihilate 4 dots in this box. So we look at what's left, and we subtract 4 because we have 4 annihilations. Kapoof, right? 1, 2, 3, 4, right? And then we're left with 3, right? We're left with 3, and we look at what's left, and then we want to delete this box here. So therefore, we have to add in 3 anti-dots to delete all the digit. The last digit will be adding in 3 anti-dots, right? But then to keep this a multiple of 7, we're adding in, 2 anti-dots for every anti-dot we added in. Because that's like 2 anti-dots next to 1 anti-dot is a negative 21. So we have 2 antidots, 2 antidots, 2 antidots. So there's 3 copies of negative 21. But then we have 1, 2, 3, 4, 5, 6 annihilations. This end box now becomes empty, and we have 6 annihilations, which is the same thing as subtracting 6. Subtracting 6, 1, 2, 3, 4, 5, 6, right? And we're left with 2 dots. And the same thing, right? We delete those 2 dots. And then what are we going to add in here? We're going to add in 2 antidots for every antidot we had in here, right? Which is adding in, again, copies of negative 21, which does not affect if our original number is divisible by 7 or not, because we're adding in a multiple of 7. Cool. So this now end box becomes empty, and we have 4 annihilations here, which is the same thing as subtracting 4. 1, 2, 3, 4. And then we're left with 3 dots next to 5 dots, which is like 35. And there it is. We know that 35 is divisible by 7. So there it is, right? This really mysterious, a lot of people think a really kind of complicated divisibility rule for divisibility by 7 is really not complicated. And it's explained extremely clearly with exploding dots. Cool. All right. Take care.